Okay, on this one, we are going to be solving for the variable. So one way, well, the main way to do this would be to say, let's take the square root of both sides, and we get 12. But why is 12 a solution? Well, because if you square it, you get back to 144. Well, isn't that true about negative 12? It sure is. So they are both solutions. And so this is your entire answer. Now, the cool kids are going to write this. They're going to say plus or minus 12 like that. And so it doesn't take up quite as much room. However, Alex isn't a cool kid like you and I. So it must be written like this with the comma. So no big deal. So that is how that one goes. How about this? Well, when I take the square root of both sides, I'm looking for a number that when multiplied by itself gives me negative 25. Well, 5 squared is positive 25, so that's out. Negative 5 squared, when squared, is also positive 25, so that's out. So it turns out that no solution. That's the symbol for no solution. So anyway, so that is what it would be. That's how we do it. Now on this one, if we square root both sides, yeah, I agree, it doesn't work out real nice, but we're not doing square root of a negative, so we do get an answer. But yeah, there's not much we can do with 19, it's prime. And like we saw a few moments ago, we get the positive and the negative solution. So positive square root of 19 and negative square root of 19. Those would both be the answers. Now let's see what else we got here. Okay, and so the answer to that one is going to be square root of 21 and negative the square root of 21. Let's see if we get anything interesting here. Now this one, when you square root both sides, you're going to do square root of a negative number, so that's out of bounds. And so again, we get no solution for the answer. Now on this one, there's more than one way to do it. The direct approach would be, hey, let's square this out and then subtract 4, combining like terms and subtract 4, and then run it through the quadratic formula. However, there's an easier way, just because of the way it's set up, which leads into the next couple of topics. If I add 4 to both sides, I get that. Now notice, the entire left side is something squared. So if I square root both sides right now, all I get is u minus 10 on the left, because the square root, whoa, that was weird. Hope that doesn't happen again. Because the square root and the square, they cancel with each other. And on the right, again, anytime you square root both sides of an equation, you get the positive and the negative square root. So now when I add 10 to both sides, I get, well, let's see, I've got 10 plus 2 is 12, and 10 minus 2 is 8. And those are my two solutions. Like I said, there's other ways to do it. And you know what? We probably should check our work on the calculator. I haven't done one of these in a while. So, let's get into it. So I'm going to go x minus 10 the squared. That's, and then minus 4. And then the other side of the equation was 0. Again, I'm just going off of the very original equation, just in case I made a mistake somewhere. Now, if I, whoops, I don't want to do that. If I go to the graph, I see that they intersect right there. So second trace 5, enter, enter, enter. And I see that one solution is 8, and we had that. Now, the other solution, this blue thing is a parabola, clearly, so it's going to come back up and intersect again. So I'm going to go to window. I'm going to push out the right side of this to like maybe 20. That should be plenty. And then I'll graph again. And then I'll get the right intersection point. So second trace 5, move my cursor over to the right one, and then 3 enters. And 12 is the other solution. Okay. Or you could go to the table and just say, all right, when x is 8, Yep, the left side of the equation and the right side of the equation, they match when x is 8. And they match again when x is 12. I don't care what the number is. I just care that they match. So, you should be checking stuff all the time. That's how you could do these. Now, you're not going to see problems like this too much, but like I said, it does lead into the next topic. Now, on this, we're going to do some magic. It'll be really cool. Okay, so we're going to do what's called complete the square on this expression so that we can factor it down to a binomial squared, kind of like that u minus 10 squared on the last problem. Excuse me. So to do it, you always add b over 2 squared. That's what you have to have, b over 2 squared, where b is your coefficient of x or v or q to the first power. Well, b is -6, so I'll add -6 over 2 squared. All righty. Now, all they want me to do is that, except I think Alex is probably wanting me to simplify this, which isn't a big deal. But I'm going to take this a little further because we got to learn to do that anyway. So when you complete the square, usually you do it so for a purpose instead of just saying, hey, I found a number. And you do it to factor the polynomial. When you factor the polynomial, it always ends up like this. This part you get for free. The only thing you don't get for free is whatever's right there. Okay. So what does go there? Well, whatever's inside those parentheses up above. Okay. -6 over 2. Okay. So this would simplify down to v minus 3 squared. Okay. Now, if I were to square that out, yeah, I get the same thing as all of that. It'd give me the same thing. Or, if I want to just see if they're the same thing, I could go to the calculator because it's fun. I could say, all right, x squared minus 6x plus, and let's see, I did -6 over 2 squared. Okay, so that was the original when I threw in the extra number. And then my final was x minus 3. Okay. Are they the same thing? Did I factor it correctly? They should match. Yep. Doesn't matter what my x value is, the y values are the same. They respond the same way. Okay, so I know I did it correctly. And hey, let's do uno mas. All right, so we're going to add b over 2 squared. Cool. And then when we factor it, which again, they're not asking us to on this topic, but they will very shortly. When we factor it, we always get that x plus something squared. What's that something? Well, that something is 10 over 2 or 5. That's it. Okay, so now we're actually going to solve the equation by completing the square. All right, get down. Here we go. So first thing we want to do is get this constant term, the term that does not have an x, get it on the other side. So I'm going to subtract 68 from both sides, and I get x squared minus 18x plus, I'm going to throw something in there in a minute, equals -68. Okay, and I left that gap there on purpose. For what purpose, you ask? Well, I want to complete the square, so I'm going to put in my magic number. B over 2 squared. Well, if I add it to the left, I need to add it to the right so that everything stays in balance, like the force. Yes, force is real. All of it. So now, like we did a moment ago on that last topic, the left side is going to factor down to x plus something squared. What's that something? negative 18 over 2. You're welcome. I know you can put negative 9 there, and that's just fine, but I'm teaching, and so I need to make it easier for you to tell what's going on. Okay, and then on the right, yeah, you just tidy it up. Negative 18 over 2 is negative 9, and squared is 81. So if we tidy it up a little, we get 13. Okay. So now we need to take the square root of both sides. X minus 9 equals positive plus or minus the square root of 13. And then we're going to add 9 to both sides. And the problem is done. And that really wasn't that many steps, to be honest. I definitely could have been longer. So that is how you solve an equation with completing the square. Or a quadratic equation, at least.